Hi, my name is Boz Rosnan, and I'd like to present Cedalion's response to this year's LWC, joint work with David Lorenz. A little bit about Cedalion. So, it is a programming language designed as a host for internal DSLs. It's best described as Prolog, plus projectional editing, plus static typing, minus side effects. So it's a purely declarative, statically typed logic programming language that uses projectional editing. So it's a programming language, not really a language workbench, but it needs a language workbench in order to exist. So the Cedalion workbench is such a workbench. It's a dedicated projectional editor for Cedalion, and it's built on top of Eclipse. It uses SWI Prolog underneath to run the Cedalion program, and consults the Cedalion program for many things, like how to project stuff, applying checkers like type checkers over the code and showing annotations, a context menu, an auto-completion menu, and more. Out of the 25 challenges in this year's LWC, our paper contains solutions for 11. And we're going to show about half of them here. We use a language named Min Imperative, which is a simple imperative language. Now, that's not a big challenge when you start off with an imperative language like you do in most other language workbenches. But in the case of Cedalion, which is a purely declarative language, this is a little more tricky, and we need to use, and we did that through big step operational semantics. Min imperative include all the things you would imagine in an imperative language, like procedures, variables, input and output, conditional and loops, and something called a block, which is a command that has a list of other commands, and it just executes them in order. Now, why am I talking about this in detail? Because every family has its black sheep, and in our case, the blocks are the black sheep of Min Imperative because of usability. Let me show you a little bit. So this is the Cedalion environment. It's on top of Eclipse. This is the editor, and it's a projectional editor. So I have here the projectional area, and here I have a textual area where I can just write something, and when I press enter, this thing goes into the projectional area. So I can create a procedure, and I have an auto-completion menu that allows me to select procedure and from an imperative, and I can give it a name, print range. There is a print range is currently undeclared, but it will be declared as soon as I press enter, and this procedure will implicitly declare it. So n and number. So it has one parameter, which is a number named n, and what I want this procedure to do is to print all the numbers from 1 to n inclusive. Let me save it so that the error is gone, and I do an assignment of I, which is a number, and I give it the value 0. And now I want to write my second command, but I can't because this slot is already a command, so I cannot put another command in this place. So what I do is copy, and I replace it with a block, and the block is empty, and I paste, and I insert an element and paste my existing command in the first place. And here I can, for example, start a while loop. That will work, but it's not very convenient. So I want to do something else. what I will do is extend this DSL mean imperative to have a sequence command which looks like which is a more Cedalion-y way to do what the block is intended to do. So so it's going to be a command named sequence AB, where both A and B are commands. So this satisfies the type checker, but this still doesn't look like what we want it to represent. So we're going to have a vertical projection where the first row is going to have two elements. One is A and the other is a semicolon. The second row is just going to be B. So when I saved the file, the projection changes everywhere, and I get this projection for the sequence. You see that it is still a sequence, but it is projected in this way from now on. So so this is a behavior, and it is my way of doing BDD development. So I can write what this describe the behavior that I want. So it should execute A and then B. This is what I expect from this sequence. And here, by the way, this is optional hiding, and I can write here a test, actually a goal that will demonstrate that this attribute holds. So I will use the execute predicate, and I want, so this is the input and this is the output. I want some output out of that, which is I just placed a variable, a free variable called out, and I want output A, and then I want to output B. I want to do it with a semicolon, but I can't. I can do it with a sequence, but that's not intuitive. So let me introduce a semicolon as an alias. So I ask you to use a semicolon as an alias for this. So now, when I mark this and request a semicolon, I will get a way to do this. So now we want to execute A and then B into some output, and that fails. You see the exclamation mark here. It fails. Why? It fails because we haven't defined the semantics of a sequence. So let's do that. We do that through the by using operational semantics, using the exec judgment. So we're going to do exec for A, B. Here we have optional hiding in the projection definition of exec, and that reflects the change of state for this, and the change of input stream and output stream. In this case, I just save it as is, and this is enough for this test to pass. But this test is very weak at this point, so I'm adding also an assertion that the output that Cedalion was kind enough to help me infer its type should be A followed by B. This should be the output string. And this test, of course, fails because we are not getting this output. So we're going to edit this and look at the process that we're doing here. It's actually what the challenge calls editing an incomplete program. This is an incomplete program. We get those blanks, which are actually free variables, and we're refining them in order for our tests to pass. So A and B. At this point, I only need to stream the output stream through that. I stream it first through B from O1 to O2, and then from O2 to O3, which is here. And that's enough for this test to pass. But this is not enough. We need to also pass the state and the input stream, and that will be covered by this test. It should pass state from A to B, and this is going to be an input of X, which is a string, and we output the same thing, and I'm going to give it foo as output and require to get foo as I'm giving foo as input and I want it as output, and this fails, of course. So for that I need to stream the state and the input stream, and they go through A first, and then through B. 2, 3, I2 to I3. And as you can see, this test passes and the sequence works. So let's replace the block with a sequence. So now I can add a while, and the while is on not equals. I'm comparing numbers, I, N. So now I assign I to be I plus 1, and again a semicolon, and I want to output a number which is I. Great. If I create a unit test, this is a unit test that is disconnected from a behavior. I want to execute print range. I need to give it a parameter, which is in this case 3, and it will give me some output, and it can evaluate the output. So it gives me 1, 2, 3, which is what I expect. So now I show this to my boss, and my boss says, yeah, but I don't like the syntax you chose for the sequence. I like it more verbose, like say I equals 0 and then while not blah blah blah. So you say, oh, I need to change that in all the places where. No, you don't. You just change the projection. So, and then, and magically it is now projected in the more verbose way all over. And then your boss looks at this and get a little nausea. He doesn't like it, so he asks you to change it back, and you just say, okay, let's change this back. No problem. So this is the nice thing about projectional editing, that the concrete syntax is not that important. What's important is the underlying representation, which remains the original representation, the SEQ. like here and here. Okay, so now you look at this code and you say, okay, we wanted imperative, we got imperative. But even in today's imperative languages like Python and Java, you don't really iterate over variables that change over the course of the that are modified by the body of the iteration. You use some kind of a for loop that works on a generator or an iterable or something like that. So luckily enough, in Cedalion we have a DSL for sets, and that DSL for sets has a concept for range, for a numeric range that we can iterate over. But we need a way to integrate this into this code. So I'm going to disable, comment out this this procedure and copy it here and remove the body. And I'm going to use a for command. A for command is a command, so I can use it in min imperative code. It has a body, which is also a command, but here the thing that we iterate over is a predicate. The predicate is so predicates are the kind of the lingua franca of Cedalion DSLs. You can every Cedalion DSL can be evaluated through a predicate. For example, min imperative code can be evaluated through the execute or the exec predicates. Exec is more low level. It has fine-grained control over the state, the input, and the output. The execute command is more high level, but we still can evaluate that through those predicates. In the case of the sets DSL, the predicate that we can evaluate sets is called member, and it looks like this. Look at the mathematical notation that it is using, and so we can iterate over the range 1 through, I want to say, n, but that will give me a type mismatch because n is a variable. It's a place where I can put values at runtime as part of the state. So when the for loop is being evaluated, n is given a certain value, and I want that value. So let me use another name, another variable. It's called n. I call it n prime. Look at how the name n prime is projected as n prime. And in the given clause, I can bind n prime, which is a number, to the value n, to the value of n at that time. Now let's output x, and when I save, you can see that this unit test passes. I can remove this completely, and I can change this to 7. The test will fail. I need to make the output a free variable again, and then it will give me the result. Okay, so we've seen some mathematical notations around the sets DSL. We've seen how we extend the language in a very fundamental way. We replaced the way we compose commands, or we added a new way to compose commands. Of course, the block still works. We added, we showed language embedding when we embedded the sets DSL into min imperative. We showed syntax migration. I can just change the projection, and the syntax will migrate anywhere in the code. And we've edited an incomplete program when we defined gradually the semantics of the sequence. What you've seen is a language workbench that has been around for almost a decade. We're working on creating a new one called Cedalion 2 that is based on today's technologies. It is going to be web-based, probably based on the Electron framework. And it is designed for improved usability and performance, with a lot of feedback from the preparation to this year's LWC. And one aspect of it is that it is going to be based on a somewhat generic projectional editor, if such thing can be considered. And I'd like to talk about that today. Thank you very much.